Hey everyone, Mr. Thrive and Survive, September 25th, 2018. This is going to be an interesting little video. Probably won't be too long, but we're going to expose another lie that is in the globe model. Interesting to see how people can explain this. I'm open for explanation, so please leave a comment if you can explain this. Let's understand a few things here. We're told that the equinox this year is on September 22nd. Actually, it just passed 3 days ago, right? This is something that happens twice a year on the equinox. Let me switch over here to a diagram. This is a rather crude diagram, but you have March and September are the equinox dates. Now, even though the word equinox suggests equal, this is where you have an equal amount of daylight in the northern hemisphere and in the southern hemisphere. It's a 12-hour day, 12-hour night, and it happens September 22nd, 23rd every year, March 20th, 21st, 22nd, give or take a day or two. And the other dates to note are the solstice dates, which is December 21st, which you have the longest night in the northern hemisphere and the longest day in the southern hemisphere, if you believe that model. And the opposite is true on the June solstice. But we're going to look at this right here. This is more important here because we have equals here on these two dates. Now, let's take a look at this another way. I know some people are more visual than others. What you should look at here is this nice little line going around the center here, which represents where the sun is on the equinox dates, here and here. Now, this is where the sun is directly over the equator, so we do have that equal amount of daylight in the northern hemisphere and in the southern hemisphere. So let's take a look at one more chart here. Here's another one. Let's take a look at it here. The vernal equinox here. You know, the Earth is supposedly tilted 23.5 degrees, which leaves 66.6 degrees. Coincidence. But again, equal day and equal night. And it's within a day or two every year, except this year it's a lie. Let's go back to it again. So here we have it. September equinox 2018 was at 6:54 p.m. They even give us the exact time on Saturday, September 22nd. So on Saturday, September 22nd, the northern hemisphere and the southern hemisphere, they both should have 12-hour days and 12-hour nights on this particular day, except they didn't. Now, I waited till today just to verify my own observations to see if they correlated with date and time. Let's take a look at that too. Now, I was first alerted to this year to take a look at it. Probably wouldn't have even paid attention by Dave Marsh in the UK. Thank you, Dave, for this. He first mentioned that the equinox was way off this year. So let's see. So I did it from my location, Phoenix. You can do it wherever you are. You're going to get the same thing, because the equinox is equinox, no matter where you are. It's equal. And what do we have here? The 22nd right here. And this was supposed to be the equinox date. Equal day, equal night. Well, I clicked on the 22nd. Sorry. Let's go to the 21st here. We have sunrise at 6:15 a.m. and sunset at 6:26 p.m. Now, I verified these times. They are correct. And we have a problem, just like Houston had.
This is Houston. Say again, please.
Houston, we have a problem.
The daylight length is 12 hours, 10 minutes. All right, so much for the 21st, or did they say the 22nd? Let's look at that one more time. September 22nd was the date. Okay, first day of autumn, September 22nd. So we come back here. The 22nd, what do we have? 12 hours, 8 minutes. It's still not the equinox date. So that's wrong. Let's go to the 23rd. Sunrise 6:17 a.m., sunset at 6:23, 12 hours, 6 minutes. Nope, not equinox. There's a 2-hour and 3-minute difference from the day before, so the days are still getting shorter. And the 24th, that was yesterday, 6:17 a.m., 6:22 p.m., still too long. Still too long. The 25th, today, 6:18 a.m., 6:20 p.m., 2 minutes too long. 2 minutes too long. It's not the equinox yet. So, tomorrow, the 26th, if everything holds true, like it has been holding true with particularly the sunsets, I've verified each one of them, Sunset tomorrow will be at 6:19, or sunrise will be at 6:19 a.m. Sunset will be at 6:19 p.m. That's exactly 12 hours. Of course, it's a few seconds more, but the actual equinox date will be tomorrow. How come they're not saying that? Well, because that would be 4 days off. So is the Earth off in its orbit? It's 4 days off. How can you explain that in the model? That's what I want to have explained. This is a lie. And people might say, I've tried to think of all the cognitive dissonance stuff that could come out. Well, this is, we're midway between leap years. Okay, well, leap year adjusts for 1 day out of 4. Correct? Each year would be a quarter year off, so we'd have a half day off right now. So that's not it. And besides, if that's it, okay, so we reached a part in the Earth's orbit where instead of the 22nd, it's taking a whole 4 days longer to get to the equinox date. So if it's off because of leap years or whatever, then we should have an issue with December, shouldn't we? December should also be late in the solstice. If the Earth is 4 days slow in its orbit to get here, then let's take a look at December and see what happens. Okay, here's December, Phoenix. Let's go down and see if the solstice date is the 21st like it usually is, or 22nd. So we're looking for the shortest day on the solstice dates. We have a daylight length of 9:56:10, 9:56:11, and 9:56:11. So the shortest day is right here. It's the December 21st, right on time. So if this is right on time, why do we have an issue where we are up to 5 days late? Now I tried to find a very simplified drawing to show you how this works. Here we are, September 22nd or 23rd they're showing for the autumnal equinox. And then we go to the solstice on December 21st, 22nd. So in its orbit, we are actually, since it's going to be the 26th, even if you use the 23rd date, it's 3 days slow in its orbit. So this year, so we're actually back here somewhere on the 22nd or 23rd. We're not reaching here until the 26th. So does that mean that we're going to go faster this year? Because we know the winter solstice is going to come up right on time. What is it this year? Well, I have a nice little theory. You've probably heard me say before that I do not believe we see the sun directly, and I think that can be proven. That's for another video. But what if the sun and its reflection that we see is on something like the moon's 19-year cycle? You know, the moon is somewhere between an 18 and 19-year cycle, one of its cycles anyway, before the moon comes back exactly where it was 19 years ago. Maybe the sun has the exact same thing, and we haven't been looking for it because we've been told that we're seeing a sun 23 million miles away, 93 million miles away in the sky, which is hocus pocus BS. But this is another lie, and I would like to see someone who defends the globe model be able to explain this. Maybe it can be explained and I don't see it. But why are we having a September 26th solstice, equinox this year? Not only that, but we were told that September 22nd week was the equinox, which is just a bold-faced lie. Again, equinox means equal daylight and nighttime. We don't have that this year. Not till the 26th. Can anybody explain this? Or is the sun really a reflection and we're seeing part of its extreme part of its cycle, whatever how many years that is in the cycle that we need to maybe pay attention to? I'm open for all kind of ideas on how this might work here, but the bottom line is it's a lie. The NASA model is just a lie. It doesn't work. Here is an exception to the rule. There should be absolutely no exceptions. We shouldn't just 1 year be 5 days behind in our orbit. No way. Any ideas? And please don't anybody say the Earth's wobbling on its axis. Look that up before you make such an ignorant statement. All right, guys, that's it for this video. God bless.